In this video, we're going to finish up the 9.5 lesson on log properties, and we're going to start with example number 3, and we're going to try and expand each of these logarithms, which means we're taking a single logarithm and we're going to expand it into multiple logarithms. So if we look at 3a, we have log base 2 of 6x. Since we are multiplying the 6 and the x, we break that apart using addition. So each piece that's being multiplied will get its own log with a base 2 because we're starting with log base 2. So we end up with log base 2 of 6 plus log base 2 of x. Nothing else can be simplified or broken apart, so this ends up being just our final answer. If we look at example B, we have log base 5 of x to the third times y to the 6. Again, we're multiplying here, so we're going to have to break that up using addition, but we also have exponents, and we're going to have to deal with those by making our exponents coefficients. However, we do this one step at a time. So the first step is to break apart the x to the third and the y to the 6. Using addition. So I end up with log base 5 of x to the third plus log base 5 of y to the 6. Since I was multiplying x to the third and y to the 6, I break those apart, each getting their own logarithm using addition. Then I deal with the exponents. So the x has an exponent of 3. That's going to go around and become a coefficient. The same thing with the y. The exponent of 6 will come around and be a coefficient. So we will end up with 3 times log base 5 of x plus 6 times log base 5 of y. And then that will be our final answer. Looking at example 3, this time we're using a natural log. So I have the natural log of a times b over the cubed root of c. Here we have kind of a lot going on. And we have to break up all of these pieces. So the first thing we do is we break apart the division first. So rule of thumb, we always break apart division first, then multiplication, and then deal with any exponents. So we're going to apply a log to the top minus the log of the bottom. The top always comes first. So this will become the natural log of AB minus the natural log of the cubed root of C. And then we kind of keep going from there. So in this first natural logarithm, I have AB. That's A times B. So I have to break that up with addition. So the A will get a natural log and the B. So we end up with the natural log of A plus the natural log of b minus, now remember that because I have the cubed root, a cubed root is the same thing as a rational exponent of 1/3. So this would be the natural log of c to the 1/3. So instead of it being a root, I can write it like this. This gives me an exponent. And remember, exponents become coefficients. So this will become the natural log of a plus the natural log of b minus 1/3 times the natural log of c. And that is our final answer. Moving on to look at number 4, here we want to combine multiple logarithms into a single logarithm. When we're doing this, we kind of go backwards. We're going to deal with coefficients and make them exponents first, and then we actually just move left to right. So in number 4, we have 3 times the log of x plus 1/2 times the log of x plus 1. Because I have coefficients, I need to make the coefficients exponents. Therefore, we end up with the log of the 3 just applies to the x. So it would be the log of x to the third plus the log of x plus 1 to the 1/2. Before I move on, I'm going to remember that a power of 1/2 is the same thing as a square root, so I'm going to rewrite this as the log of x to the third plus the log of the square root of x plus 1. Then, because I'm adding the logarithms, that means I'm going to multiply x to the third times the square root of x plus 1 to condense them into a single logarithm. So this will end up equaling the log of x to the third times the square root of x plus 1. And then this is my final answer. The last problem is example number 5. And again, we want to combine or simplify this into a single logarithm. So we have 3 times the natural log of s plus 1/2 times the natural log of t minus 4 times the natural log of t squared plus 1. Again, we have coefficients. So those coefficients will become exponents. So I'm going to make all of the coefficients exponents. So the 3 will become an exponent on the s, the 1/2 will become an exponent on the t, and the 4 will become an exponent on the t squared plus 1. This gives us the natural log of s to the third plus the natural log of t to the 1/2 minus the natural log of t squared plus 1 to the 4th. Again, I'm going to remember that a power of 1/2 is the same thing as a square root. So this will become the natural log of s to the third plus the natural log of the square root of t minus the natural log of t squared plus 1 to the 4th. From here, I just move left to right. So I have addition first, so that means I'm going to multiply s to the third and the square root of t. So we'll end up with the natural log of s to the third times the square root of t minus the natural log of t squared plus 1 to the 4th. Now, because I am subtracting, to condense these to a single logarithm, I'm going to divide what comes first, s to the third times the square root of t, by what comes second, t squared plus 1 to the 4th. So this will become the natural log of s to the third times the square root of t over t squared plus 1 to the 4th. And then this is my final answer. Note that my final answer has just a single logarithm of one thing. Okay, so that finishes the last 3 examples of lesson 9.5, and then we'll kind of go from there. Thanks.